Now this is objective solved example question number 38. Now this question is binomial theorem, not an easy question. Because see how the way it goes, it's not an easy question. I'll tell you what is the difficult part here when it'll the difficult step will come. Now this trinomial expansion is given in the question. Trinomial because there are three terms, and we have to find the value of this n minus 1 into ar 2n minus r plus 1 into ar minus 1 equal to, and also just have a look at the choices are in terms of ar plus 1. All of them are ar plus 1 in terms of ar plus 1. So we have to just figure out what will be, what the simplified form of this expression would be in terms of ar plus 1. Now I write this expansion in summation form. That will be, that will make the steps easy if you write this in summation form. Now the first thing I'm going to do is I'll differentiate this with respect to x. Now is it a difficult step? When I say differentiate with respect to x, it's not a difficult step because these are the coefficients of the expansion. You can see ar plus ar minus 1, and these are the coefficients of the coefficients, and coefficients of the coefficients come when we differentiate an expansion. Like if we have normal expansion 1 plus x square plus x cube, when we differentiate this becomes 0, this is 1. Now see here, it becomes 2x, so power comes in coefficient. 3x square, this power comes in coefficient. So when we differentiate, we are shifting powers as coefficients. So that is what we need to do here. Definitely we need to do here, because when we can see coefficients in as the coefficients of these coefficients. These are powers coming down as coefficients. So we differentiate this is n times 1 plus x square to the power n minus 1. Now I'm not sure whether you have done derivative, otherwise we'll apply chain rule. We differentiate this with respect to x, then we need to multiply this with the derivative of 1 plus x square with respect to x, that is 1 plus 2x. So if this derivative part is not clear, you can leave it for the time being till we study derivative. Differentiate, n comes out, power reduces, and then we multiply with the derivative of this, equals to, on right hand side also when we differentiate all these, this power will come in coefficient r ar x to the power r minus 1, right? Now generally when we have to find the relationship between the coefficients, we equate appropriate coefficient on both the sides. That is what we are going to do in this question. But before that, to regenerate this series, otherwise we cannot find any of the coefficients here. We cannot find any of the coefficients here because we have changed it to n minus 1. Changing it to n minus 1 means all these terms will change, all these coefficients will change. So this step is little difficult. Derivative was not difficult, but this step is difficult, that we have to regenerate this series. We are multiplying this with this, multiply both sides by this expression to regenerate. So you multiply this with 1 plus x square. So the first term will be, we take r out, sigma of x to the power r minus 1. R varies from 0 to 2n. Oh sorry, we can't take the expression of r, can't take this out. And then so when we multiply this with x, it becomes summation rar x to the power r. R varies from 0 to 2n. The last time when we multiply this with x square, the power of x will increase by 2, rar x to the power r plus 1. So now in this expression, we have to equate the appropriate power of x on two sides, and just to equate x to the power r on both sides. Right, right? So x to the power r, will see, will from two sides we'll get x to the power r from this side, n into x to the power r from here, that is ar, and then plus 2n. 1x is already there. From this we find x to the power r minus 1, so that the product is x to the power r, so it is ar minus 1. Similarly, you'll find appropriate coefficients here, right? So you can complete this yourself now.